All right, welcome back. We're going to be talking about how good mathematicians do math, the 8 standards for math practice. We're going to continue with math practice 2, but I want you to remember that this is kind of the format that we will be taking notes. Math practice number, what it says. We'll clarify any words or phrases that we don't understand. After we do that, we'll write it in our own words. We'll have an activity or an example to help us understand what it means. And then we will do that reflection piece. What are you going to do to be better at this particular math practice? There are some times, specifically today, where we're actually going to switch these two things up, where I'm going to do the activity first, and then I'll talk about what it means in our own words. But I will always explain that when that happens. So to get started, remember our notes from last time. We have our circle map of how good mathematicians do math. Here's all of our information on math practice 1. And now let's get started. Here is math practice 2, reason abstractly and quantitatively. So what does this actually mean? You might remember from last year when we saw these two photographs, or I guess not photographs, but we saw these two images. And you'll remember that we talked about how they're both beautiful in their own ways, and they're both representing the same type of thing, and they both have like their own reasons for existing. So they both have the tree in the foreground, you can see that. They both have the sort of mountainscape in the background. But you can also see the stars. You can see different features, like here's the swirliness of the galaxy, and you can see the swirliness there. You can see all of the little stars, and you can see all of the stars. And so, again, I really want to emphasize that they're both beautiful. And maybe you have an opinion about which one is more beautiful, but they are both beautiful in their own ways. One other thing that I would like to point out is that they are representations, I've mentioned this, they're representations of that same thing, okay? Even though they look different, they're about the same thing. So this ties in very nicely to abstractly and quantitatively. We're first going to talk about reasoning abstractly. Basically, that means we're going to use symbols to simplify or to shorten. So for example, I have w plus 6 is equal to 11. Can you guys look at this? W plus 6 equals 11. And can you figure out what w is equal to? Raise your hand if you can figure it out. Raise your hand if you already have figured it out. Give you another second then. How do we raise hands up high? Okay, good. What is it, Jude?
Me?
Yeah. Try again. Yeah, it's 5. W is equal to 5. And you were able to do that very quickly, right? However, do you know what W represents in the real world? What do you think W represents in the real world? What are your thoughts? Does it represent whales? Does it represent windows? What do you think it represents? Dan, what do you think? A number? But yes, and it does represent a number, but in the real world, what would that number represent in the real world? Give me some examples. Lainey. Walruses. The world. It represents worlds. Okay, and guess what? You're all wrong. Water. You're all wrong because it really represents the width of a rectangle. Okay, so let's take a look at this. It says the length of a rectangle is 11 inches, which is 6 inches more than its width. What is the width of the rectangle? Now, I'm talking about the width in inches. Did you know that just by looking at this equation? Of course not. How could you know that, right? But now that I've represented it quantitatively, now you know that it represents the width of a rectangle in real life. Now, if I gave you a choice, would you rather solve this problem or would you rather solve this one? Which one would you choose? Who says they'd rather solve this one? Why? Because you could do it like in a snap of a finger, right? You guys looked at it and you're like, oh, well, W is obviously 5, and you did that without having to really think about anything else. You did that so quickly, you couldn't even read through the whole problem before solving this one. The length of a rectangle is 11 inches, which is 6 inches more than its width. What is the width of the rectangle? You can't even read through it in the time that it takes to solve that. So understand, again, these two situations are talking about the exact same thing. Is one of them more simple to solve? Absolutely. But are they still showing the same information? Also, yes. And that's what we're really talking about with reasoning abstractly and quantitatively. Okay, so don't write this down yet. I'll tell you when it's time to write down. But I want you to make sure that you're paying attention and understanding what we're really talking about. When I say abstract reasoning, I'm really talking about how we do math. So when we're doing math, we're decontextualizing a situation. What that means is we have this whole real life situation, but we're not focusing on the real life aspect of it. We're just focusing on different pieces. So we're taking out the story and just focusing on the symbols. That's what it means here. Represent it symbolically. We're looking at symbols. What it means is we're going to write equations to solve. We're going to do calculations. We'll simplify expressions, etc. We're going to do all of those super mathy things, and we're going to take it out of the real world. However, the opposite of that is quantitative reasoning. It's why we do math. We do math because we have questions about the world, and it's a lot easier to answer those questions by doing it symbolically. But the quantitative is why we're doing that math. So it means contextualizing, meaning we're going to interpret the symbols and understand what they mean in a real life context or a real life situation. It means we're going to use units of measure. We're going to understand the meaning of quantities, find applications outside of the classroom, etc. Now it's going to be time to write down. Again, I've got our visuals to help us remember. Abstract, that's how we do math. Quantitative is why we do math. In the abstract, I'm writing equations to solve, performing calculations, simplifying expressions, etc. So we should probably write this down so that we understand what abstract means. Quantitative. Reasoning quantitatively requires units of measure, contextual meaning, that means meaning within a story or a situation. And we're looking for applications outside of just the classroom. Is there math in the real world around you? Yes. That's why we have math class, to teach you how to use that math in the real world. Give you guys a few more minutes to continue writing that down in your notes. Okay, so now that we've talked about abstract and we've talked about quantitative, now is your chance to put it in your own words. What does this mean? So this means ... and now you're also going to write down, what does it mean when I say reason abstractly and quantitatively? Think about that last slide. Abstract means we're using symbols and equations. Quantitative means we are using units of measure, and we are putting it back into a real life situation. As you guys are writing this, please remember that this means you are going to be going onto Canvas tonight, and your homework is going to be putting this in Canvas. This means ... You'll type it up into Canvas.
Is that today's?
Yep, that's today's homework. I'll go back one more time so that you can see. Remember, abstractly means we're using equations. We're doing calculations. Quantitative means we're using units of measure and making it make sense in the real world. So reason abstractly and quantitatively, this means ... Who needs more time on this? Okay. I'll go another 30 seconds and then we are going to move on. So we're going to go to our for example section. So write down for example. Don't write anything else down yet. Just write down your for example. And here is your example. A class trip is scheduled for an amusement park. Group admission prices are $31 per student, and parking is $18 per bus. Okay, so again, $31 per student, and parking is $18 per bus. It says complete the table, here's the table, to show the cost of $10 or 10, 20, 30, and 40 students and 2 buses. So we're not writing any of this down yet, okay? I'll show you what to write down. I just want you to have a good understanding of what's happening in this problem first, okay? All of this is very quantitative. It's a real life situation. Students are going to an amusement park. It's $31 for each of those students. And of course, we're taking the students on buses. the bus is going to have to park, so parking is $18 per bus. Now, the school is trying to get a feel for, how much this is going to cost. So they're collecting those permission slips from the students. First there's 10, then 20, then 30, then 40. So they're just trying to figure out how much all of this is going to cost. Now, this is what I want you to actually write down in your notes. Instead of writing all of that stuff, just write down this. Amusement park admission, $31 per student. Just kind of simplifying it so that you're not spending the whole time writing that whole paragraph. And it's $18 per bus. And the first part of this problem is asking us to figure out for 10 students, 20 students, 30 students, and 40 students, but we also need to remember that we are definitely, for sure taking 2 buses. So we don't need to worry about how many buses, it's for sure going to be 2 buses. So remember that. We just need to figure out for 10, 20, 30, and 40 students. Yes, you can use your calculators. Yes, you can work with your grapes. I'm sorry. An email came through and it said grades and I got completely distracted all at the same time. All you need to worry about is the students, not the grapes, but the students. 10, 20, 30, 40 students. Talk with your group members. Talk with those in your table. How are we going to do this? Students online, I'm going to pause the video and let you guys think about this. We'll come back together in just a few seconds. It's probably a good idea to think about this, even though it's silly. What if there were 0 students and we are still taking 2 buses? Now, I know that's not really going to happen, but I think that's a good starting place. So even if I was taking 0 students but 2 buses, how much would it cost? Sheldon? How did you get that? Yep, 2 buses times 18 per bus means that it's going to be $36, right? So that's a good starting point. I put it up here because it's not really necessary, but it still might be helpful to think about that. So then what if I'm taking 10 students on 2 buses? Now that would be nice, right? You get basically a whole bus to yourself. You get like 5 seats to yourself. What would this be, Michael?
328.
And how did you get that?
There's 10 students, so you times 31 times 10, which is 310.
Good.
Then you add the bus.
And so what did you get? I only heard the 300.
328.
Are you sure?
Yeah. I'm pretty sure.
Nope, because how many buses are we taking?
Oh, 2.
2 buses.
Oh,
So we would need to add 36, not just the 18.
yeah.
So 10 times the 31 students is 310, right? But then we also need to remember that we're going to take that 310
It's 336.
and add the 36. So I get 346. That's better. Yep, good.
That's where I took that.
Okay, now what if it's 20 students? How much is that going to cost? 20 students. I want to see hands. You guys had lots of chances to do this on your own. You guys are just making more work for yourself at home for homework. I want to see hands. Sheldon, I appreciate it. And then you already helped me out once, so I want to see different hands besides Sheldon and Michael. Sheldon, how did we do this? 20 times 31. Good, and then I would add the 36 for the 2 buses. Now what is that? 20 times 31 is equal to what? 600 what?
38.
Not yet. I think you still made a mistake. What's 20 times 31? Good thing we have calculators, right? So even if you didn't calculate it before, you know what you should be typing in right now. 20 times 31, Nevaeh. 620. There it is. And then, like Sheldon said, after we have that amount, we take that amount, 620, and we add 36. So what do we get? 600. Yes, Aiden. I don't think so. Maybe I'm making a mistake, but I don't think so. What's 620 plus 36? Rhett? Yeah, 656, I think. Aiden, look back at your calculations and see if you can find your mistake. Okay, 30 students. I want to see fresh new hands. 30 students. What is this going to be? Michael, I heard from you. I want to hear new students. 30. How do we, what is the number and how do we find it?
It's 930.
It's 31 times what? Okay, but you're still forgetting something. I don't want just the cost of the students. I want the total cost. What is it that Nevaeh is missing here? The student cost is going to be $930, but is that the only thing that I'm paying for, guys? No, what else do I need to pay for? Dan? The bus. So 930 plus the 36 is going to be, Kaden?
948.
Please double check. We are not paying for one bus, Kaden.
Oh.
How many buses? We are paying for 2 buses, which means every time I should be adding 36 for those 2 buses, getting me $966. This last one, I hope that we have learned from our mistakes and that we're not going to keep making those same mistakes. 40 students, what is the total cost for 40 students, knowing that we are taking 2 buses? Jacob.
So the total cost of the students would be $1,200. 76. Sorry.
1,276?
Yeah.
1,276. Please tell me how you got 1,276.
I took the number of students that are all together on those 2 buses, and then I took the cost. No.
I have the total number of students is 40, but what do I do with that?
And then the park admission would be 31.
Okay.
And for that, I got 1,240.
Good. And then what do I do with that now that I have 1,240 for the students to get in? Plus the parking for the buses, yes. So 1,240 plus 36 is our 1,276. Now we're going to go even more abstract because this is still fairly quantitative. We can see the student numbers, we can see the cost numbers, but let's really abstract this. Let's write an equation to show the cost, which is going to be C. So I want the total cost. If 2 buses transport, so how much for these 2 buses? $2?
No, they're 18 per bus.
Which,
So it's 36.
36, because there's 2 buses. So that's going to be 36. And we're transporting S students. So I'm abstracting this because now I don't know if it's 10, 20, 30, 40, or if it's a completely different number. I'm going to be using S. So it's like adding an S here at the end of the table. Okay? What is that going to look like then? How can I write an equation? What am I going to do if instead of having the exact number, now I'm given a variable S? Look at the patterns. Look at everything that we already did so far in the table. Can we continue that for the rest of the table? Kaden, what are your thoughts?
I think you need S times 34.
Yeah, because we still have our students times the admission cost. Good.
And then you would plus 36.
Then we'd have to add 36 because we still have to park our 2 buses. And what does that give me? Every time it gave me the total cost, right?
Yeah.
Only what am I using to represent the total cost instead? C. We wrote our equation. This is abstract. Okay? Now, let's finish this up. What is the total cost for 78 students and 2 buses then? And this is the beauty of this math practice, is it just made everything so simple. See how abstract this is? but I'm telling you 78 students. So what does that mean? 78 is S. We're just going to take that S, and instead of using an S, we're going to use 78. 78 times 31. Then we have to add the $36 to park the 2 buses, and that's going to give us our total cost. Good thing you have calculators. 78 times 31 plus 36. Dan, what did you get?
2,454.
Say that one more time for me, please.
2,454.
2,454. That is our cost. Now again, this right here, guys, this is abstract. Did we solve the problem? Yes, but this is abstract. And I want to make the abstract quantitative. So I would change that to be $2,454 for 78 students on 2 buses. That is taking the abstract and making it quantitative. We solved the problem, yes, but now we want to make it make sense in the real world. This is our quantitative answer. Quantitative. Do they mean the same thing? Yes. One of them makes sense in a math world. One of them makes sense in our real world, the real life situation. And now to finish this, class ends in just a few minutes. Now it's the reflection piece. I can reason abstractly. Let's try that again. I can reason abstractly and quantitatively by what? What are you going to do to reason abstractly and quantitatively? Perhaps you'll write something like, I can reason abstractly and quantitatively by using equations and making sense of in the real world. Remember, this is using symbols. And this is real world. So what are you going to do? This is your reflection time, your goal setting time. That's it for today on Math Practice 2, Reason Abstractly and Quantitatively. Please don't forget that your assignment is to enter the meaning in your own words into Canvas. Thanks, and we'll see you next time.